The morning sun filtered through the crystal walls of awe. Kepler Station as Professor Zix Tal prepared for another semester at the Advanced Robotics Institute. The professor's crystalline body sparkled in the light as he moved through his classroom, checking each workstation one final time. This was the most important robotics course in the known galaxy, and students traveled from 12 different worlds to attend. Zixtal felt proud as he looked at the enrollment list. The Ethereal Collective had sent 3 of their brightest minds. The Silicon minds from Nexus 7 were represented by their top computational theorists. Even the gas giant dwellers from Kepler Prime had managed to send a student in their special atmospheric suit. Each species brought thousands of years of technological advancement and peaceful development. The first students began arriving in the main hall. Cathara floated in her containment suit, her gaseous form shifting colors with excitement. Veltar rolled in on mechanical treads, the silicon entity's processors humming with anticipation. Quindle appeared as a ball of controlled energy, barely contained within a specially designed field generator. "Welcome, students," Zixtal announced, his voice carrying through translation devices. "You represent the finest minds from the most advanced civilizations in our galaxy. Together, we will push the boundaries of robotic engineering to new heights." The students settled into their assigned spaces, each workstation specially designed for their species' needs. The atmosphere buzzed with excitement and friendly competition. These were beings whose homeworlds had never known war, hunger, or natural disasters. Their technology reflected this peaceful existence, elegant, efficient, and built for perfect conditions. That everything changed when the transport bay doors opened again. That 3 figures walked through the entrance, and the entire room fell silent. They looked similar to the Ethereal Collective in basic shape, but something was different. These beings moved with purpose, their eyes constantly scanning their surroundings. Their clothing was practical rather than decorative, and they carried bags that looked worn from heavy use. "Ah," Zixtal said, consulting his datapad. "Our exchange students from the Sol system have arrived." A collective gasp echoed through the room. Sol system meant only one thing: Earth. The whispers started immediately. "Deathworlders," someone hissed in the universal translator. "Class 12 hazard rating," another student murmured. "Why are they here?" Jake Morrison stepped forward first. He was tall and sturdy, with short brown hair and steady green eyes. His hands showed small scars from years of working with tools and machinery. Behind him came Lisa Parker, shorter with blonde hair pulled back in a practical ponytail. Her bright blue eyes missed nothing as she examined the alien technology around them. Sam Rodriguez brought up the rear, lean and wiry with dark hair and brown eyes that seemed to find humor in everything. "I am Jake Morrison," the first human said simply. "This is Lisa Parker and Sam Rodriguez. We are here to learn about robotics." Professor Zixtal's crystalline form flickered, the equivalent of a nervous cough. The Institute's board had insisted on accepting these exchange students as part of a new diplomatic initiative. Zixtal had argued against it, but politics had won over academic judgment. "Welcome to our institute," Zixtal said formally. "Please take seats in the remedial section." The other students shifted nervously as the humans walked to the back of the classroom. Cathara's gaseous form turned a worried shade of purple. Veltar's processors whirred faster with anxiety. Everyone had heard stories about Deathworld species. Earth was classified as a Class 12 Deathworld, a planet so dangerous that most civilized species considered it completely uninhabitable. The surface temperatures varied wildly. Violent storms could appear without warning. The ground itself moved and shook regularly. Worst of all, the planet was filled with creatures that fought and killed each other just to survive. How could any intelligent species develop proper technology in such chaos? The very idea seemed impossible to the other students. Their own worlds were stable, predictable places where technology could be refined over thousands of peaceful years. Now then, Professor Zixtal continued, trying to regain control of his classroom. Let us begin with basic principles. Robotic engineering requires precision, elegance, and efficiency. We build our machines to last for centuries without maintenance, to operate in perfect environmental conditions, and to serve the peaceful advancement of civilization. Jake raised his hand. What happens if something breaks? The question caught Zixtal off guard. Breaks? Our technology does not break. We design it to perfection. But what if it does? Lisa asked. What if the environment changes? What if the power source fails? These are not concerns for advanced civilizations, Zixtal replied stiffly. We control our environments. We maintain our power systems. Failure is not acceptable. Sam chuckled quietly. Everything fails eventually. The comment sent another wave of whispers through the room. The alien students could not understand such thinking. In their experience, technology either worked perfectly or was replaced with better technology. The concept of designing for failure seemed primitive and wrong. Perhaps, Zixtal said coldly, the Deathworld students would benefit from remedial courses in basic engineering principles before attempting advanced robotics. But Jake, Lisa, and Sam just exchanged glances. They had grown up on a world where Murphy's Law was not just a joke, but a daily reality. If something could go wrong, it would go wrong, usually at the worst possible moment. Their entire technological philosophy was built around this simple truth. The semester was about to become very interesting. As the other students returned to their excited discussions about theoretical robotics and perfect engineering solutions, the three humans quietly examined the alien technology around them. They saw elegant designs and advanced materials, but they also saw single points of failure, delicate components, and systems that would collapse the moment anything unexpected happened. Professor Zixtal dismissed the class early, overwhelmed by the disruption the humans had caused just by asking simple questions. As the alien students filed out, still whispering nervously about their new classmates, Jake, Lisa, and Sam remained behind. This is going to be fun, Sam said with a grin. Lisa nodded, already thinking about how to adapt the alien designs for real-world conditions. They have amazing materials and energy sources, but their engineering philosophy, is completely backwards, Jake finished. They design for perfection instead of survival. The three humans gathered their worn bags and headed for the door, unaware that they were about to revolutionize robotics education and challenge everything the galaxy thought it knew about engineering. Behind them, Professor Zixtal stood alone, in his perfect classroom, wondering what chaos these Deathworlders would bring to his orderly academic world. The second day of class arrived, with Professor Zixtal announcing the first practical assignment. The alien students gathered around their workstations with excitement, while the three humans sat quietly in the back corner of the lab. Today you will design and build a basic maintenance robot, Zixtal explained, his crystalline form reflecting the lab's bright lights. This robot must be capable of performing routine cleaning and minor repairs in a controlled environment. You have 1 week to complete this project. The alien students immediately began accessing their databases, pulling up thousands of years of established engineering principles. Their designs would follow proven patterns that had worked perfectly for countless generations. Cathara's gaseous form swirled with concentration as she began designing an elegant floating robot. Her creation would use anti-gravity fields and energy manipulation to clean without ever touching surfaces directly. It was beautiful and sophisticated, following all the traditional rules of her people's technology. Vel Tars, mechanical form, word, as the silicon entity calculated the perfect mathematical ratios for efficiency. The robot design that appeared. On the screen was a marvel of computational theory. Every component precisely optimized, every movement calculated to minimize energy expenditure. Quindles. Energy form pulsed as the being designed a robot that was more living light than machine. It would clean by breaking down dirt and debris at the molecular level, reassembling useful materials while disposing of waste through a controlled energy conversion dock in the back of the room. The humans approached the problem differently. Jake examined the available materials and immediately started separating them into piles. "What do we have to work with?" he asked Lisa and Sam. "Standard alloys, energy cells, basic sensors," Lisa replied, checking the supply cabinets. "Nothing too fancy, but sturdy enough." Sam picked up a damaged component from the recycling bin. "Look at this power coupling. It failed because it had no backup systems. One tiny surge and the whole thing burned out." "That's their problem right there," Jake said, sketching rough designs on paper instead of using the computer systems. "Everything has to work perfectly, or nothing works at all." The humans' approach puzzled their alien classmates. Instead of accessing databases of perfect designs, they seemed to be planning for things to go wrong. Instead of using the most advanced materials available, they chose simpler, more robust options. Lisa started building what looked like a crude box on wheels. The other students giggled at its simple appearance compared to their elegant creations. But as they watched more closely, they noticed something strange. The human robot had multiple sensors performing the same function. It had backup power systems. Most confusing of all, it had easily removable panels that allowed access to internal components. "Why would you want to take it apart?" Kethara asked. "Floating over to observe." "For repairs," Lisa answered simply. "When something breaks, you need to be able to fix it quickly." "But it should not break," Kethara protested. "Proper engineering prevents failure." Sam looked up from his workstation where he was building something that looked like it had been assembled from spare parts. "Everything breaks eventually. The question is what you do when it happens." Jake's robot was taking shape as well. It looked rough compared to the alien designs, but it had 3 different cleaning systems that could work independently. If one failed, the other 2 would continue working. If all 3 failed, the robot could still return to base and report the problem. "This is inefficient," Veltar observed, rolling over on mechanical treads. "Why use 3 systems when one perfect system would suffice?" "Because perfect doesn't exist in the real world," Jake replied. "Murphy's Law, anything that can go wrong will go wrong." The silicon entity's processors hummed with confusion. "This Murphy's Law is not in our databases." Who was this Murphy? What credentials did he possess? The humans exchanged glances and tried not to laugh. "It's not really a law," Sam explained. "It's just ... reality. Things fail. Environments change. Power fluctuates. Good engineering accounts for this." As the week progressed, the differences between human and alien engineering became more apparent. The alien robots were masterpieces of design, sleek, efficient, and elegant. They used advanced materials that were stronger than anything found on Earth. Their power systems were incredibly sophisticated, drawing energy from quantum fluctuations and zero-point fields. The human robots looked like they had been built in someone's garage. They used simple materials, redundant systems, and crude-looking interfaces. But they had something the alien designs lacked. They were built to survive when things went wrong. Professor Zixtal watched the humans work with growing frustration. Their approach violated every principle of proper engineering he had taught. For decades, they seemed to deliberately choose inferior materials and inefficient designs. Worst of all, they kept asking questions about failure modes and emergency procedures. "What if the main power system fails?" Lisa would ask. What if the cleaning fluid runs out? Sam would wonder. What if it encounters something it wasn't designed to handle? Jake would inquire. These questions made no sense to Zixtal. Proper engineering meant such problems simply did not occur. The humans seemed obsessed with planning for disaster instead of preventing it through superior design. On presentation day, the alien students displayed their creations with pride. Cathara's robot floated gracefully through its demonstration, cleaning surfaces without physical contact while maintaining perfect efficiency ratings. Veltar's creation moved with mathematical precision, calculating optimal cleaning patterns in real time. Quindle's energy-based robot cleaned at the molecular level, leaving surfaces literally perfect. Professor Zixtal scored each design based on traditional criteria: elegance, efficiency, and adherence to established engineering principles. The alien robots scored excellently in all categories. Then came the human's turn. Jake's robot rolled forward on simple wheels, looking crude next to the sophisticated alien designs. But when it started cleaning, something unexpected happened. The cleaning brushes adapted to different surface textures automatically. When one sensor became dirty, backup sensors took over seamlessly. The robot even detected a small spill that the other robots had missed and cleaned it thoroughly. Lisa's box-like creation performed even better. When Professor Zixtal deliberately blocked one of its cleaning systems, it switched to another method without stopping. When he introduced a minor power fluctuation, it automatically reduced non-essential functions to maintain operation. Sam's patchwork robot was the most surprising of all. Despite looking like it was held together with spare parts, it handled every test Zixtal threw at it. More importantly, when one component actually did fail during the demonstration, Sam simply opened an access panel, swapped in a replacement part, and had the robot working again within minutes. The human designs score poorly on aesthetics and theoretical elegance. Professor Zixtal announced with satisfaction. They failed to meet basic standards for sophisticated engineering. But privately, he was troubled. During his evaluation, he had noticed something disturbing about the alien robots. They worked perfectly under ideal conditions, but even minor environmental changes caused problems. A small power fluctuation made Cathara's robot unstable. A single dirty sensor confused Veltar's creation. Quindle's energy-based design failed completely when the molecular composition of the test dirt was slightly different than expected. The human robots, meanwhile, had continued working through every disruption he could think of. As the students filed out of the lab, chattering about their grades and comparing their elegant designs, Professor Zixtal remained behind. He stood looking at the three human robots, still sitting where their builders had left them. They looked crude and primitive compared to the alien masterpieces, but they also looked like they would still be working long after the elegant alien designs had failed and been forgotten. For the first time in his long teaching career, Professor Zixtal began to wonder if there might be more than one way to achieve excellence in engineering. The thought disturbed him deeply, challenging everything he had believed about technology and civilization. In the corridor outside, Jake, Lisa, and Sam walked together toward their quarters. "Think he's starting to get it?" Sam asked. "Give him time," Lisa replied. "They've never had to deal with real-world conditions. Their technology is impressive, but fragile." Jake nodded. "Wait until they see what happens when things really go wrong. That's when Deathworld engineering shows its true value." Behind them, alien students continued discussing the superiority of their designs, unaware that their fundamental understanding of engineering was about to be challenged in ways they could never imagine. 2 weeks into the semester, Professor Zixtal announced the second assignment. The alien students gathered eagerly, still confident in their superior technology, despite the strange performance of the human robots in the previous project. "Your next challenge involves hazardous environment cleanup," Zixtal explained. You must design robots capable of operating in dangerous conditions, areas with radiation, toxic chemicals, extreme temperatures, and unstable terrain. The alien. Students looked puzzled. Most had never encountered truly dangerous environments. Their homeworlds were carefully managed, peaceful places where such hazards simply did not exist. Cathar-Jez's gaseous form shifted nervously. How dangerous are we talking about? Level 3 atmospheric variance? Mild electromagnetic interference? Professor Zick-Stahl consulted his datapad. Level 9 radiation fields. Corrosive atmosphere with random chemical composition changes. Ground instability, including seismic events. Temperature fluctuations from -50 to +200 degrees. The room fell silent. These conditions were beyond anything the alien students had ever imagined, let alone designed for. Their technology was built for controlled environments where such extremes were prevented by careful planning and advanced infrastructure. Veltar's processors whirred anxiously. Surely there must be some way to stabilize the environment first? Remove the hazards before sending in robots? No, Zick-Stahl replied firmly. The robots must work in the conditions as they exist. This is the challenge. In the back of the room, the three humans exchanged glances. These conditions sounded like a typical Tuesday on Earth. The alien students spent days struggling with concepts that seemed impossible to them. How could you design electronics to work when radiation levels kept changing? How could mechanical systems function when the very air might dissolve metal components? How could you plan robot movements when the ground itself might shift without warning? Their designs reflected this confusion. Cathara created a beautiful floating robot enclosed in multiple force fields, but the power requirements were enormous. Veltar designed a mathematically perfect machine that could theoretically handle any single hazard, but would fail immediately if two problems occurred at once. Quindle's energy-based approach simply could not cope with environments that would disrupt its delicate energy patterns. Meanwhile, the humans worked with quiet confidence. Jake started by making a list of everything that could go wrong. Radiation will fry electronics, so we need shielding and hardened components. Corrosive atmosphere means we need materials that can resist chemical damage. Seismic activity means the robot needs to stay stable when the ground moves. Temperature swings will make metal expand and contract, Lisa added. We need flexible connections and materials that can handle thermal stress, plus backup systems for when the primary ones fail. Sam was already sketching designs. What if we make it modular? If one section gets damaged, the rest can keep working. And if it gets stuck or broken, we can send in another robot to fix it, or carry the important parts back. Their approach baffled the watching alien students. Instead of trying to create one perfect solution, the humans seemed to be planning for multiple failures simultaneously. Jake's robot took shape as a heavily armored crawler with tracks instead of wheels. The tracks could be replaced in the field if damaged. The robot had 3 separate computer systems running the same programs. If radiation fried one, the others would take over. The entire machine could be sealed against corrosive atmosphere, but individual sections could be opened for repairs if necessary. Lisa designed something that looked like a mechanical spider. If one leg was damaged, it could continue on the remaining legs. If the main body was compromised, it could detach damaged sections and continue with a smaller, but still functional form. Most importantly, it could adapt its movements to changing ground conditions in real time. Sam's creation was the strangest of all. It looked like a collection of smaller robots that worked together. If part of the swarm was destroyed, the rest could continue the mission. The individual units could share power, information, and even physical components. If one robot found something useful, it could call others to help or pass along tools and materials. This is madness, Veltar observed, watching Sam swarm robots. Practice coordinating with each other. How can you control so many variables? How can you predict their behavior? You don't, Sam replied simply. You make them smart enough to figure things out for themselves and tough enough to survive when they make mistakes. Professor Zixtal watched the human designs with growing concern. They violated every principle of elegant engineering. They were crude, redundant, and overcomplicated. Worse, they seemed designed with the assumption that failure was not just possible, but inevitable. The day of testing arrived. The Institute had constructed a special chamber that simulated the hazardous conditions described in the assignment. Warning signs covered the entrance, and safety systems monitored every aspect of the test environment. The alien robots went first. Despite their sophisticated designs and advanced materials, they struggled immediately. Ketharos force field. Robot worked well initially, but the changing radiation levels drained its power faster than expected. When the battery ran low, the force fields weakened, and corrosive gases damaged the delicate internal components. Veltar's mathematically optimized robot performed perfectly until a minor seismic shift caused it to lose balance. The fall damaged a critical sensor, and without that input, the robot's perfect calculations became meaningless. It wandered in circles before finally shutting down to prevent further damage. Quindle's energy-based robot lasted only minutes. The chaotic electromagnetic environment disrupted its energy patterns so severely that it could barely maintain cohesion, let alone perform cleanup tasks. Then came the human robots. Jake's armored crawler rolled into the test chamber, like it was designed for exactly these conditions. Radiation that had crippled the alien electronics barely affected its hardened systems. When corrosive gas ate through one of its sensor cables, backup sensors automatically activated. A seismic event that would have destroyed the other robots merely caused Jake's machine to adjust its stance and continue working. Lisa's spider robot was even more impressive. It scuttled over unstable terrain with ease, automatically adjusting its gait when the ground shifted. When one leg was damaged by a chemical spill, it simply rerouted around the damaged limb and kept moving. The robot even used the damaged leg as a probe to test dangerous areas before exposing its functional limbs. Sam's swarm robots were the most spectacular of all. The individual units worked together like a single organism, sharing information and resources instantly. When radiation destroyed several units, the survivors quickly reorganized into new working groups. When a chemical leak threatened to overwhelm one section of the swarm, other units rushed in to help, while the damaged robots retreated to safe areas for repairs. But then something happened that nobody had planned for. A containment field in the test chamber failed. Real danger suddenly filled the room as toxic gases began leaking out and radiation levels spiked beyond safe limits. Emergency alarms screamed as automatic systems tried to contain the breach. The alien robots, already struggling with the simulated hazards, immediately shut down as their safety protocols activated. They were too valuable and sophisticated to risk in genuinely dangerous conditions. But the human robots continued working. Jake's crawler immediately detected the real emergency and shifted from test mode to actual hazard response. Its armor, designed for Earth's hostile environment, easily handled the radiation and toxic gases. The robot began sealing the containment breach using materials from its own supply compartments. Lisa's spider robot coordinated with Jake's crawler, using its mobility to reach damaged areas that the crawler could not access. Together, they began stabilizing the situation while Institute staff evacuated the area. Sam's swarm robots spread throughout the chamber, working as emergency repair teams. Some units sacrificed themselves to block toxic gas leaks, while others bypassed damaged systems to restore containment field power. Within 20 minutes, the emergency was contained. The human robots had not only survived real danger, but had actively worked to save the facility and everyone in it. Professor Zixtal stood in the observation deck, watching the 3 crude human machines complete their emergency repairs. Around him, alien students stared in stunned silence. Everything they thought they knew about engineering had just been proven wrong. "How?" Cathara whispered, her gaseous form pale with shock. "How did they do that?" Professor Zixtal finally understood. These humans came from a world where such emergencies were normal. Their entire technological philosophy was built around the assumption that disasters would happen and machines needed to function anyway. They did not build for perfection. They built for survival. For the first time in his long academic career, Professor Zixtal realized he had something to learn from his students. In the test chamber, Jake, Lisa, and Sam's robots finished their emergency repairs and began the original cleanup assignment. They worked efficiently and methodically, treating the simulated hazards as just another day at the office. Because for them, it was the alien students watching from the observation that began to understand that. Word of the emergency spread through Kepler Station faster than plasma fire. Within hours, everyone knew about the Deathworld students who had saved the Advanced Robotics Institute when their crude machines succeeded, where sophisticated alien technology had failed. The atmosphere in Professor Zixtal's classroom changed completely. The alien students no longer whispered fearfully about the humans. Instead, they watched Jake, Lisa, and Sam with new respect and burning curiosity. Cathara was the first to approach. Her gaseous form swirled nervously as she floated over to Lisa's workstation during the next lab session. "I have been thinking about our previous assignment," Cathara said through her translator. "My robot failed because it was too dependent on perfect power supply. Perhaps. Would you be willing to work together on the next project?" Lisa looked up from her sketches and smiled. "I'd like that. Your anti-gravity technology is incredible. I've never seen anything like it." "But it is fragile," Cathara admitted, her form shifting to a marist orange. "It requires precise conditions to function. Your designs seem to work no matter what happens." "That's because we expect things to go wrong," Lisa explained. "On Earth, if you don't plan for failure, you don't survive long enough to learn from your mistakes." Professor Zixtal announced the new assignment: designing robots for deep space exploration. The machines would need to operate independently for years without maintenance, in environments where communication delays made remote control impossible. "You will work in teams of 2, Zixtal said. "One alien student, one human student. Perhaps we can learn something from different approaches to engineering." The professor's crystalline form flickered with uncertainty. Everything he had believed about technology was being challenged, but he could not argue with results. The human designs worked when nothing else did. Cathara and Lisa immediately partnered up. As they began planning their exploration robot, the differences in their thinking became apparent. "We need anti-gravity for efficient movement," Cathara suggested. "My people have perfected this technology over millennia." "Anti-gravity is amazing," Lisa agreed. "But what happens if the system fails? We need backup propulsion." "Fail? But why would it fail?" Cathara asked. "The mathematics are perfect." Lisa pulled up images of Earth's surface on her data pad: hurricanes, earthquakes, volcanic eruptions, meteor impacts. "This is where I come from. On Earth, perfect systems fail all the time because the environment doesn't care about mathematics." Cathara studied the images with growing horror. "Your world tries to kill you constantly. How do you survive?" "We build things that work even when everything goes wrong," Lisa said simply. "What if we combined your anti-gravity with simple chemical? Rockets as backup? And maybe wheels for ground movement if both flight systems fail?" The combination seemed wasteful to Cathara at first. Why carry the weight of systems you expected never to use? But as Lisa explained more about redundancy and failsafes, the gas giant dweller began to understand Dot at another workstation. Jake found himself partnered with Veltar, the Silicon entity. Their project was equally challenging, the logical, mathematical mind trying to work with the practical, experience-based approach. I have calculated the optimal configuration, Veltar announced, projectors displaying perfect geometric designs. This exploration robot will achieve maximum efficiency in all standard environments. Jake studied the design. It was mathematically beautiful, but he saw problems immediately. What if it encounters something that isn't standard? What if the terrain is different than expected? The calculations account for all known variables, Veltar replied. Unknown variables are irrelevant because they cannot be quantified. But that's exactly when you need your robot to work, Jake said. When you encounter the unknown, let me show you something. Jake pulled up his own rough sketches. Where Veltar's design was optimized for specific conditions, Jake's was built to adapt. The robot had multiple movement systems, various sensors, and modular components that could be reconfigured based on what it discovered. This is inefficient, Veltar observed. You are carrying unnecessary weight and complexity. Maybe, Jake agreed. But when this robot finds something unexpected, it can adapt. Your robot might be more efficient in perfect conditions, but mine will still be working when those conditions change. Slowly, Veltar began to understand. The Silicon entity's mathematical mind started calculating not just optimal performance, but also failure modes and adaptation strategies. It was a completely new way of thinking. Sam found himself working with Quindal, the energy being. Their partnership faced unique challenges as they tried to combine Sam's mechanical approach with Quindal's energy manipulation abilities. I can create robots from pure energy, Quindal explained, form pulsing with excitement. They require no physical materials and can be reconfigured instantly. That's incredible, Sam said, genuinely impressed. But what happens if something disrupts your energy patterns? What if there's electromagnetic interference? Quindal's glow dimmed. The robots would dissolve. But such interference is rare. In civilized space. Space isn't civilized, Sam replied. It's full of radiation, magnetic fields, and energy phenomena we don't understand yet. What if we combined your energy manipulation with physical components? The energy systems could provide fine control and adaptation, while mechanical backups ensure the robot survives disruption. The idea fascinated Quindal. In their species' millions of years of existence, they had never considered combining energy, manipulation with crude matter. It seemed primitive, but Sam's examples from Earth showed how such hybrid systems could be incredibly robust. As the weeks passed, these unusual partnerships produced remarkable results. The alien students learned to think about failure, adaptation, and survival. The humans learned about advanced materials, energy manipulation, and computational theory that was centuries ahead of Earth science. Cathara and Lisa's exploration. Robot combined elegant anti-gravity with practical backup systems. When the anti-gravity failed, chemical rockets would activate. If those failed, the robot could deploy wheels and continue as a ground vehicle. If everything failed, it could still serve as a stationary research station, transmitting data until rescue arrived. I understand now, Cathara said as they tested their hybrid design. You do not build for perfection. You build for persistence. Exactly, Lisa replied. On Earth, we have a saying, anything worth doing is worth doing badly. Sometimes a crude solution that works is better than a perfect solution that fails. Jake and Veltar's robot was even more impressive. The Silicon entity's mathematical precision, combined with Jake's practical experience, created something neither could have achieved alone. The robot could calculate optimal strategies like Veltar-S designs, but it could also adapt and improvise like Jake's machines when calculations proved insufficient. "Your approach adds chaos to my order," Veltar observed. "But this chaos creates flexibility, resilience. These are not mathematical concepts, yet they have mathematical value. Sam and Quindell's creation was the most radical of all. The energy being's manipulation abilities allowed the robot to reconfigure itself constantly, while Sam's mechanical components provided stability and reliability. The result was a machine that could literally reshape itself to meet changing conditions while maintaining core functionality no matter what happened." Professor Zixtal watched these collaborations with amazement. The hybrid designs surpassed anything in the Institute's 1,000-year history. More importantly, they represented a fundamental shift in engineering philosophy. The other alien students, working in traditional partnerships, produced elegant and sophisticated robots. But when tested against unexpected conditions, the human-alien hybrid machines consistently outperformed them. "How is this possible?" demanded Threnovic, a proud student from the Crystal Worlds. "Their designs are crude and inelegant. They waste resources on unnecessary backup systems. Yet they work when ours fail," Kathara replied quietly. Her partnership with Lisa had changed her perspective completely. Perhaps elegance is not the only measure of good engineering. Professor Zixtal found himself in an impossible position. His entire academic career was built on the belief that sophisticated, elegant design represented the pinnacle of engineering achievement. The humans were proving that sometimes crude, robust design was actually superior. The revelation forced him to question everything. If Deathworld engineering principles could improve upon millions of years of civilized technology development, what else might be wrong with accepted academic wisdom? As the semester progressed, the alien students began adopting human engineering concepts. They started planning for failure modes. They included redundant systems in their designs. Most importantly, they began testing their creations under harsh conditions instead of just perfect laboratory environments. The humans, meanwhile, gained access to materials and technologies beyond their wildest dreams. Lisa learned to incorporate anti-gravity into her designs. Jake discovered computational techniques that made his robots far more intelligent. Sam found ways to manipulate energy that transformed his mechanical systems into something approaching magic. But perhaps the most important change was cultural. The alien students stopped seeing the humans as primitive D. The final week of the semester arrived with an atmosphere of excitement and nervous energy. Professor Zixtal stood before his transformed classroom, looking at students who had changed dramatically over the past months. Alien and human partnerships now worked together naturally, sharing ideas and techniques that had never been combined before. "Your final assignment," Zixtal announced, his crystalline form reflecting the lab lights, "will test everything you have learned. You must design robots capable of exploring and establishing a base on a newly discovered world." The professor activated the main display, showing orbital images of a planet that made the alien students gasp in horror. The surface writhed with violent storms. Lightning storms raged across continents. The ground itself seemed to shift and crack constantly. Volcanic activity painted the sky in angry reds and oranges. "The planet designation is Kepler 442b, Zixtal continued. "Atmospheric composition changes randomly due to volcanic activity. Seismic instability makes ground-based construction extremely difficult. Weather patterns are completely unpredictable. Radiation levels fluctuate wildly due to magnetic field variations." Cathara's gaseous form turned pale yellow with fear. "Professor, these conditions are beyond anything we have studied. This world appears to be a Class 12 death world." "Indeed it is," Zixtal confirmed. Your robots must not only survive in these conditions, but establish a permanent research base. They must operate independently for at least one Earth year without support or maintenance from orbit. The alien students looked terrified. Even with everything they had learned about human engineering principles, the challenge seemed impossible. But in the back of the room, Jake, Lisa, and Sam exchanged glances and tried not to smile. The planet looked remarkably familiar. The teams immediately began planning. The old alien approaches would have been useless here, but the hybrid designs, combining human and alien technologies, offered real possibilities. Cathara and Lisa worked on environmental adaptation systems. Lisa's experience with Earth's chaotic weather, combined with Cathara's advanced atmospheric manipulation, created robots that could literally create safe zones in hostile environments. Their machines could generate force fields to deflect debris, process toxic gases into breathable atmosphere, and even harness the planet's electrical storms for power. The key is not fighting the environment, Lisa explained as they tested their prototype. It's learning to work with it. Those storms look dangerous, but they're also massive sources of energy if you can tap them safely. Jake and Veltar focused on construction systems. Jake's knowledge of building in unstable conditions merged with Veltar's advanced materials, science to create robots that could literally grow structures from local materials. Their machines could analyze soil composition, extract useful elements, and fabricate building components that would flex with seismic activity instead of breaking. Mathematical precision is important, Jake acknowledged as he watched Veltar calculate stress distributions. But you also need to build in tolerances for the unexpected. No calculation is perfect when the ground is trying to shake your building. Apart, Sam and Quindle developed the most ambitious system of all, self-replicating maintenance robots that could repair and upgrade themselves using whatever materials they found. Sam's modular design philosophy, combined with Quindle's energy manipulation, created machines that could literally evolve to meet changing conditions. The planet will try to destroy whatever we build, Sam explained. So we make machines that can rebuild themselves faster than the planet and break them down. The other teams followed similar approaches, combining human resilience with alien sophistication. The designs that emerged were unlike anything seen before in galactic engineering. They were robust enough to survive devastating conditions yet sophisticated enough to accomplish complex tasks. Professor Zixtal watched the development process with amazement. In just one semester, his students had advanced beyond anything he had seen in decades of teaching. The fusion of human and alien engineering principles was creating revolutionary technology. The day of final presentations arrived. Each team demonstrated their robots in increasingly harsh simulated conditions. The machines performed magnificently, adapting to challenges that would have destroyed purely alien designs while accomplishing tasks impossible for purely human technology. But Professor Zixtal had prepared one final test. Before we conclude, he announced, I have a confession to make. The planet I showed you, Kepler 442b, is not newly discovered. In fact, it has been known to us for quite some time. The students looked puzzled. Why would he lie about something so basic? Zixtal activated the display again, but this time he showed detailed surface images instead of orbital shots. Cities became visible through the storms, structures that clearly showed signs of intelligent construction. Technology that was obviously advanced, yet built to withstand the planet's hostility. This world is already inhabited, Zixtal continued. It has been home to an intelligent species for thousands of years. A species that has somehow thrived in conditions that would kill most civilized beings. Recognition dawned on several faces. Cathara's gaseous form swirled with sudden understanding. Veltar's processors hummed as calculations fell into place. The planet designation Kepler 442b is the scientific name, Professor Zixtel said quietly. But the inhabitants call it by a different name. They call it Earth. The alien students sat in stunned silence. Everything they had just designed, all the survival systems, the adaptive technologies, the robust engineering solutions, it was all for dealing with conditions that the humans lived with every single day. You mean, Cathara whispered, they come from that place? Every human comes from that place, Zixtal confirmed. Every piece of human technology was developed to work in those conditions. What we call primitive Deathworld engineering is actually sophisticated survival technology refined over thousands of years of necessity. The revelation transformed everything. The alien students finally understood why human designs seemed so paranoid about failure, because on Earth, failure meant death. They understood why humans built redundant systems, because backup systems were the difference between survival and extinction. Your assignment was not really about building robots for an unknown world, Professor Zixtel continued. It was about learning to see familiar challenges from a completely different perspective. Every day, humans deal with conditions that would terrify most civilized species. Yet they have not just survived, they have thrived. Jake stood up slowly. Professor, if I may ask, why did you do this? Why show us Earth without telling us? Zixtal's crystalline form flickered with something that might have been embarrassment. Because I needed to understand. For my entire career, I have taught that sophisticated, elegant engineering represents the pinnacle of technological achievement. You three challenged everything I believed. The professor turned to address the entire class. I wanted to see if our most advanced students could solve the challenges of your homeworld using our most sophisticated technology. The answer is that they could not without learning your approaches first. But we're not better engineers than you, Lisa protested. We just learned in a different school. Earth taught us things that peaceful worlds never could. Exactly, Zixtel agreed. And that is why this semester has been the most important in this institute's history. We have learned that there is more than one path to engineering excellence. Sophistication and elegance are valuable, but so are resilience and adaptability. Sam raised his hand. So what happens now? Professor Zixtal's form brightened. Now we establish new exchange programs. Human engineers will study with us to learn advanced materials science, energy manipulation, and computational theory. Our students will study on Earth to learn survival engineering, adaptive design, and crisis management. Study on Earth? Kethara's form turned pale again. On the actual planet? In carefully controlled conditions, Zixtal assured her. But, yes, if we are to truly understand Deathworld engineering, we must experience the environment that created it. The semester ended with a transformation that none of them had expected. The alien students no longer saw humans as primitive Deathworlders, but as engineers who had mastered the most challenging classroom in the galaxy. The humans no longer felt like outsiders, but like teachers sharing hard-won knowledge with eager students. More importantly, both groups had learned that diversity in thinking led to better solutions than either could achieve alone. Human resilience, combined with alien sophistication, created technology that surpassed what either species could build independently. As the students prepared to leave for their home worlds, they carried with them more than just technical knowledge. They carried a new understanding that strength comes in many forms, and that sometimes the best engineering solutions come from the most unexpected places. Professor Zixtel remained in his classroom after the students departed, looking at the hybrid robots they had created. These machines represented a new chapter in galactic engineering, one where survival and sophistication worked together instead of in opposition. For the first time in his long academic career, Professor Zixtel realized he had learned more from his students than they had learned from him. The Deathworld